There is a regular hexagon with the vertices A0, A1, A2, A3, A4, A5, A6. Then we have to find the product of lengths of A0, A1, A0, A2 and A0, A4. Let us try to draw a rough sketch of a regular hexagon in the unit circle. Radius, that means circle with unit radius, that means the radius is equal to 1. Right, the regular hexagon will look something like this. Right, this is the center. Let's say A is the center. AB equals to AC equals to AE, AD. All of these line segments will have length 1 because this is the center of the circle and this is the radius. Right. Now this is a regular hexagon. Right. That means there will be 6 equilateral triangles. So each angle is equal to 60 degrees in all of these equilateral triangles. Right. Obviously this point is 1, 0. Now we can clearly see this point. If we take this point as C, then that would be center of AB. AB's length 1, the center is actually 0.5. So the x coordinate is actually equal to 1 by 2. Right. Now at the same time, sine 60 degrees is the length of this y coordinate by hypotenuse, which is 1. So sine 60 is root 3 by 2, which is nothing but this y by 1, which is nothing but root 3 by 2. Right. So this coordinate C is actually half and root 3 by 2. But now by symmetry, what is this point? This point will become minus half and root 3 by 2. Right. And this point will become minus half minus root 3 by 2. Right. This point is minus 1 comma 0. Just by symmetry, we can clearly say, right. So the vertices of all 6 points we can clearly define that way. Right. Just by looking at the uh, just by using sine 60 or tan 60 or whatsoever. Now, what is that is asked A0, A1. A0, A1. If we call this as A0, A0, A1, because this is an equilateral triangle, this length will be definitely 1. Right. And what about A0, A2? If this is A1, this is A2, this is A0, then the length of this one would be equal to 1 minus half. That is 1 plus half whole square and 0 minus 3 by 2 or minus 0 minus root 3 by 2, that is root 3 by 2 whole square. This is nothing but 3 by 2 whole square plus root 3 by 2 whole square, which is nothing but 9 by 4 plus 3 by 4, right. Which is nothing but root 12 by 4, which is root 3. So length of this distance is root 3, right. That is A0, A2. Now A0, A4. A0, A1, A2, A3, A4. A4 is this point. So obviously there is this distance should be equal to this distance because both are symmetric in nature, both are mirror images with respect to this x-axis. So this distance is also root 3, this distance is root 3, and this distance is 1. So the product of three distances is 1 into root 3, which is equal to 3. Right, guys? Simple problem. We just need to establish what exactly the coordinates of this given hexagon. And after that, it is pretty straightforward.